Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. We are on the struggle bus tonight. We're gonna try to track James Webb and take a look at the first star that the James Webb is currently looking at and using to align its mirrors. But we've got some issues to deal with tonight, and I'm not sure exactly why it's happening, but I have a bad feeling that this deep space camera is on its last leg. We're having some very unusual issues I've never seen before tonight, and it's not to do with the telescope. It is very much to do with the camera itself. We'll get into it in a minute. For now, this is a star in Ursa Major, near the star that James Webb is currently looking at. So we're going to move over to the star that the James Webb is looking at, and hopefully we can look at it ourselves if this camera will hold out just a little longer. Okay, stand by. I'm going to move the telescope. Okay, when this slew completes, it should be pointed at HD 84406 in the constellation Ursa Major. Not what I wanted, guys. Okay. There we go. Alright, so let's see what happens. Let's see what happens with the 30-second exposure. While it does that, I'm going to go into some of the issues I'm experiencing tonight. As soon as I set up the camera, I could tell something wasn't right. I was getting a really weird pattern of light. It looked like kind of teeth going across the image, and it was as if something really bright was shining in the telescope, but nothing was. And then it would stop communicating with the camera control software would just freeze up. Maybe it's a software side issue, maybe it's a USB issue. I tried changing USB ports, I tried changing USB cables, none of that has helped, and now it's doing this. This right here, on the left side of the image, you see that brightness there. It shouldn't look like that. That is really not good, that is really not normal. I have a feeling that a lot of these symptoms are being driven by a failure of the camera's shutter. It's taking a long time to initiate the exposure in some cases. In some cases, the exposures come out half illuminated, but it's not the very sharp Venetian blinds effects I used to see that were clearly an effect of the computer or the USB somehow causing interference in the image. This is definitely got a gradient to it, and that suggests it's a real optical effect. Okay, so there we go. There's the star. That bright star near the middle is the star that James Webb is actually looking at right now, which is pretty cool. That's the very same star they're using right now to align the 18 segments of the James Webb Space Telescope mirrors. And you can also see a selfie image that they published, I believe it came out just today, of the mirror taken by NearCam with a special lens looking back through the telescope at the primary mirror. and you can see one of the segments reflecting starlight very brightly. So they actually have an image. There we go, that's a decent image. They have an image of this star, and see right now, I can't even get it to abort. It's like the software is darn near crashing. And I don't think it's the software's fault. I think the camera's not communicating properly, or it's getting hung up when trying to take exposures. I have a feeling it is not doing well. It's like it's trying to position the shutter, and it's not able to. Or sometimes the shutter gets caught mid-exposure and is partially open or partially closed when it should be the other way around. So something is very wonky here, and I have a feeling it's bad news for this old camera. Fortunately, I have a backup camera identical to this one that I can swap out. Not tonight. It's quite a process to take the adaptive optics unit off, and that's the other issue. It's not guiding properly. I push north, I push south, it keeps moving the telescope the same direction. I'm not sure if that's a telescope issue, maybe, or an incompatibility there. I don't think it should be, though I have heard rumors that at least in the early versions, the initial versions of this telescope's firmware, auto-guiding does not work in altitude azimuth mode, which is what we're in tonight. So we're using the 11-inch Celestron, which is a beautiful scope, but I don't have a wedge for it, so it is aligned out as, so the tracking's not going to be perfect, and it will be subject to field rotation, all of that, everything else. So I'm going to take a picture. This one's actually going to be saved. The last one was not actually saved automatically. This one will be. So there's that limitation, but nevertheless I was hoping I could auto-guide despite being an alt-az and use the adaptive optics, but the minute I tried to move the telescope north or south, it kept moving the star the same direction rather rapidly. So I abandoned that idea and disconnected the cable that would run into the auto-guide port. So adaptive optics is out. You can see the rotation, actually. You can see the field rotation there between those last two exposures. But it's okay. It's decent enough. You can clearly see the star there. We've got a decent image here. So we're going to proceed like this and hopefully be able to see the James Webb. So James Webb, I've heard reports that it's as dim as magnitude 17 in some cases. Normally I would be rolling in here with the 8-inch on the wedge to do long exposures, that kind of stuff. But there are some edge cases, or at least some use cases, where having more aperture is beneficial even if you can't run longer exposures, particularly if you're trying to track something that is not only dim, but moving. And so you have a very limited period of time to get it above the noise level of the image before it moves on to a new set of pixels on the CCD if you're not actively tracking it. So that's what we're dealing with here tonight. So we have a better chance of actually seeing it tonight with the 11-inch. So that's what we're going to try to do next. I'm going to move the telescope over to where I expect to find the James Webb, and hopefully the go-to is accurate, and hopefully we get a good shot there. So we'll see what happens next with that. So I'm going to let this last image come in. And see, there's something goofy there. Something goofy going on there. That does not look like a 30-second exposure. At least it doesn't look like the others, does it? You could only see the one star, and you can't see anything else, and it's a lot dimmer. So I think maybe the shutter was closed most of that exposure when it should have been open. I have a bad feeling this camera's just in tough shape, which is a shame. But we'll deal with it. Alright, so stand by 1 second. We're going to switch targets here. And we're going to try to find the James Webb itself. I'm glad we were able to at least get HT 84406, James Webb's first target. That's cool to see. But let me pull up the current coordinates. So we're now 10:12 p.m. Eastern Time. That's going to be 27. So that's going to be 0312 Universal Time. And based on what I'm seeing, It seems like this version of NexStar software wants the coordinates in J2000 format. I don't know if that's really the case or not. I haven't absolutely confirmed it, but it seemed to have much better pointing accuracy with J2000 coordinates just now on this star. James Webb, of course, is going to be in a very different part of the sky, so maybe that was artifactual. Maybe the natural pointing error of the scope lined up with precession in such a way that they canceled each other out. But I'm gonna go with it. I'm gonna assume it wants J2000 coordinates, which is different than the old LX200. The LX200 wanted J now or coordinates at the equinox of date. So let's see. We're now 3:13 universal time, so there's the coordinates. Okay, it's not moving super fast anyway. Okay, I'm gonna plug this into the scope, and I'll be right back. Well, that's interesting. I thought I'd have better clearance than that. I don't. So, new problem. I cannot actually move the scope to the proper altitude. So, this actually provides an opportunity here to fix things a little bit. Because the thing is, I do have another camera, an identical SBIG ST-2000, which I can fire up to, let's see, I'm going to change this temperature here. I'm going to start warming this camera up and getting ready to shut it down. I'm going to completely swap out the optical train a little bit here. Well, not the telescope, but the back end system. I'm going to take off the adaptive optics, the SBIG, put on a star diagonal, which will give better clearance, and then I'm going to have to refocus, of course, but that's not too hard. But I'm going to put the other SBIG on, the one that should be working, knock on wood. Hopefully we have at least one functional SBIG camera in-house. So I've got the other ST-2000, the backup camera. I'll put that on. It doesn't have the adaptive optics unit attached right now, which is actually a good thing considering the scope can't clear at this altitude. James Webb is too high, and the scope can't travel that high without colliding with itself. So I've stopped the slew mid-slew, and I'm just gonna swap out the camera. We'll have to refocus on a star. We can do that closer to the portion of the sky where James Webb is located. And the good news is we, at least in theory, won't have to be dealing with a wonky camera unless it's not the camera's problem, unless there's something going on with the computer or the software that's causing all of this. So we're going to test that theory right now by switching out cameras. So give me just a second. Let me let this camera warm up gradually a little bit more. Come on, baby. Let it get above 0 degrees Celsius on the temperature. And then I'll shut it down and swap it out. Yeah, it's a challenging night, but we'll get through it. Fortunately, we've got Plan B ready to go. Did the classic reboot? No, I haven't actually rebooted, so it could be the... I mean, it's not out of the question that it could be the computer or the software, but this is a pretty powerful computer, and it doesn't usually give me issues. heck, it never gives me issues, so this is unusual. I did reboot the camera and the camera's connection several times. That didn't help. But the computer side I didn't reboot. I was running low on time before the webcast, so trying to troubleshoot this thing. So it could be that. We'll find out. But right now we're going to find out if it's the camera hardware or not by swapping out the camera hardware. So one way or the other, we're about to get an answer. Yeah, so anyone joining late, no, that is not James Webb. That is actually the star that James Webb is looking at right now. I guess it was kind of beneficial, accidentally, that the last exposure got screwed up probably by the shutter of the camera, and so that all the other stars got blocked out, and that's the only star you can see in the image now. But for anyone joining late, that is the star that James Webb is currently studying to align its mirrors. So if you look at that picture they released today of the 18 spots that they took a mosaic of that represent the same star repeated 18 times by the 18 different mirror segments, it's that star. Yeah, I have the same procedure as the James Webb. I got to cool it down. In this case, I'm deliberately warming it back up to shut it off. And I think we're at a point now I can go ahead and do that. So I'm going to disconnect the camera and turn it off and swap out the camera hardware entirely. So give me a few minutes and enjoy the music in the meantime. And I'll be back probably in 5 to 10. So stand by. Alright, let's see how lucky we can get with connecting a new camera, refocusing, all that good fun stuff. Okay, this camera's ready to cool down. Let's get it down to -5 to start with. I put new desiccant in here recently, so it should be okay, but I don't know. We'll see. First of all, hopefully we got pointing accuracy good enough to get our star of interest in there, Procyon. No guarantees at all. Nope. Okay, we got nothing. Well, that's fun. Okay, we got a very nice picture of nothing. Okay, let me try something else. Okay, I can see it in the viewfinder. It ain't close to the camera though. I might have whacked things out of whack moving the camera out in. Yeah, okay. Let's see. I got an idea. We're gonna gradually redo the alignment, if I can get lucky. Hey, I got lucky. Okay. Okay, that should be good enough to get some focusing done. Oh, you can see some dew forming on the front corrector plate there. So just like James Webb took a picture of its own mirror, I'm essentially taking pictures of my own mirror. Well, the whole optical train, really. Including the front corrector plate. You can see how it's kind of got that darkening around the inner side there. It indicates we're getting some dew forming. Okay. Cranked up the dew heaters to maximum, so hopefully that helps. Also, while it does that, temperature, let's drop that down to -10. It overshot quite a bit to -5 because it's colder than the camera was expecting. Now, I guess it's important to note that unlike my 8-inch LX200, I do not have a Batonov mask for this thing. So the backup, or not the backup camera, the 11-inch telescope, I have no Batonov mask, which definitely makes focusing more of a challenge, and it won't be as precise tonight as I normally like it to be, but we'll deal. Okay, that didn't do quite right. Let's see if we can get a better... Oh, no, I don't want subframe. Let's see if we can get a better subframe going. The camera, you might notice, is much more responsive to my commands now. I think it's pretty cleared, sadly, that the other camera is having some sort of malfunction. I can try to see if I can send it into SBIG for servicing for God knows how much money. I don't know if they'll even take it, though, because it's such an old model, it's kind of out of date. Okay. Let's do 0.1 second exposure. Not sure. Yeah, this camera does weird things with CCD blooming on bright stars, the backup camera. I don't know why. The prime camera never did this. But it only does it on really bright stars, but it does do it consistently on really bright stars, which I'm not sure what that says about it, but just have to live with it. It's also got a nasty column defect running right through the middle. But dark frame takes that out, at least. Okay. Yeah, as I say, finding precise focus with this is a bit tricky. At this point, I have to look at the fainter stars to really see what I'm doing, and if I'm making things better or worse. It's not really proper way of doing this, but it is what it is. At some point I'll call it well enough and leave it alone. Might have gone too far. Yeah, it's drifting pretty good too, isn't it? But I think I knocked the alignment out a little bit. But we can fix this. Okay, I'm going to call that good enough on the focus. So now we have to deal with the other issue, which is called we're out of alignment. So we'll deal with this. NexStar. Okay, let's get this star centered. Oop, wrong way. Okay. Maybe need to decrease the rate a bit. Okay. That's good. Okay, now I need to realign. Come on. Come on. Other way. Okay. Okay, we'll call that good enough. Now we'll replace the other alignment star and try to fix this mess. There we go. Thank goodness for the finder camera. This scope's got a nice upgraded finder. Now it's time to align on Rigel. Okay, align success, it says. Hopefully that's good enough. We'll find out. As a test, we'll go to Beetlejuice and see if it finds it properly. Alright, here comes Beetlejuice, hopefully. Well, that's not encouraging, is it? Yeah, that's a close but no cigar moment there, so I think the answer is to actually go realign on Capella, which was what I originally aligned on, which is a better alignment star, so give me a second. Okay. Okay, so we're now aligned on Capella. So let's see how we do. Okay, let's see how we do with Betelgeuse. Hey, it gets it in the frame. Amazing. Okay. That's not bad. Alright, so we have successful go-to. Alright, so now let's try to go to the James Webb. First, though, I'm gonna let's see, I'm gonna do a go-to. I'm gonna practice going to the J2000 right ascension and declination, see if that's the correct answer or if it wants it in J now. I think it wants it in J now, actually, looking at this. Let me see something. Yeah, I'm pretty sure it does. Alright, let's see if it wants it in J now. 1, 5, 6, 2, 1.3 plus 07 24 39. Okay. It's going to move out and then it's going to move back into view, in theory. Yep, there it comes. Yep, that did it. Okay, so it wants J now, so I gotta send it to the James Webb Space Telescope coordinates processed to the current date and time. So what that means for anyone using JPL Horizons, you should download the coordinates, the apparent, or not the astrometric coordinates, the apparent coordinates, right ascension and declination of the telescope, and send your telescope to there if you're using a NexStar telescope, at least a relatively modern one. There was some version of NexStar that they supposedly switched from using JNOW coordinates to, or switched from using J2000 coordinates to using JNOW coordinates. That's what I've heard online anyway. Okay, If we are in luck, we should now be pointed at James Webb. So, we're going to need a longer exposure than 1/10 of a second, that's for darn sure. So we'll go up to 30 seconds. And then we will turn on autosave. Oh, we don't want 2x2. Let's start with 1x1. 30-second exposures, 1x1. Let's go. All right, here we go. It's been a long journey tonight, but hopefully we'll meet with some success now. We'll see. It will take a 30-second exposure, then it will take a 30-second dark frame to subtract hot pixels. So I do expect to see a lot of noise in this first frame. Yeah. That's to be expected. And there's no telling just yet if we do have a detection of James Webb. The moon's also out tonight, and it's going to contribute a significant amount of just light noise to the image. We can also plate solve. That's true. We can plate solve and just verify that we're in the right region. If it comes down to it. But hopefully, with the next 30-second exposure, we'll see something moving other than just field rotation and, you know, tracking inaccuracies. At this high altitude over the horizon, we are going to get significant field rotation relatively quickly. You can already see it in the frame. Like, the stars at the edges are more elongated than the stars in the middle. That's because we're tracking altitude azimuth, so that puts a pretty hard limit on how long we can run the exposures. Yeesh, yeah. And the whole frame there is kind of blurred a bit. While that does that, I'm going to fire up Deep Sky Stacker here and just grab those latest 2 frames. Oh, something went goofy. It didn't save my pictures of the star, the alignment star for James Webb. Yeah. Not really picking it up just yet. At least it's not apparent to me. Of course, we do have the issue of, well, the tracking ain't great in altitude azimuth. I wouldn't expect it to be. And also, James Webb, you know, it's not moving super duper fast. That's a potential confounder as well. It might be worth taking the exposures down to 15, maybe? Just trying to compensate for the lack of guiding on here. Could try to throw the autoguider on. I mean, it can't hurt, I guess. Well, it can kind of, but it's because the autoguider is going to guide on a star just out of the field of view, so everything in the field of view is going to rotate more from field rotation by guiding on that star. Maybe better to just suffer with the periodic error. I'm gonna try stacking, and I'm gonna save the aligned images. Okay, I'll clear those out, and I'm just looking at things. I know you guys can't see it at the moment, but I'm looking at things in Deep Sky Stacker. Oh, it only did the first and the fifth. Okay, that's funny. Real funny. Funny guys. Okay, I don't see anything obviously moving just yet. Tabbing back and forth. Well, maybe. It's hard to say. That's just poor tracking, I guess. Oh, is there something there? I don't know. I'm probably imagining things. Okay, what I'm going to do now is I am going to plate solve. Okay, I'm going to take this over to astrometry.net. Upload. I'm going to upload the first frame. And then pull in the coordinates, look at the astrometry, and actually show an overlay of where we expect JWST to be in the frame, see if there's anything in the frame. I mean, that's just the most direct way to try to get on it and try to verify if we're on it. First of all, it'll tell us, are we even in the right field of view? Is it in the field of view, or are we just outside of the field of view? We want observer table. Right. Okay. So we're gonna, while it's doing that, while it's trying to solve it, clear list, clear list. Yeah, come on, solve it. While it tries to solve it, I'm gonna see if I can pull in. First of all, I guess I should move these into a temp directory. Okay. Hard to say, hard to say. Come on, astrometry. Figure it out. Still waiting for processing to start on astrometry.net. Sometimes their whole site goes down too, which is so much fun. I do have the ability to run it locally. I'm seeing a bunch of recently submitted images and not a whole lot of recently solved images. I'm thinking their server may be having trouble, which is, oh no, they did have a solve recently. Okay, so it's just running slow, but it is running. Come on, guys. Okay, I've got some new images that are well tracked enough that they stacked. And tabbing through them, trying to see if I can find anything moving. Not seeing anything, but again, I know it's moving slowly at this point, so it won't be as obvious as it was the first couple nights that I tracked it. Alright, astrometry, please tell me you still don't have a solution for me. Are you kidding me? I may have to go to my desktop and fire it up and... yeah. It would be faster at this point, I suspect. I might be waiting for a train don't come on the astrometry site right now, unfortunately. Alright, so I'm gonna head over to the desktop with my images. Oh, great. I don't have my USB stick on me. Okay, I'll be back in a few minutes. I'm gonna copy the frame here over to my desktop and astrometrically solve it on the desktop and see what we're looking at. See if we're even in the right spot. We might need to reposition the telescope slightly. That's one possible reason, so we need to rule that out, which I need to do with astrometry, so I'll be right back. Alright. It's there. It's extraordinarily faint. It's a good thing I'm using the 11-inch telescope. It's here somewhere-ish. I can see it in time-lapse when processing the pictures. The trouble is, there is this vignetting going on in the frame, and that's making it more difficult to see. If I stop right now and take some calibration frames, it'll be easier to see when I reprocess the images again. I'm looking at it on the desktop, and I can see something moving right where James Webb should be, but it is just above the noise floor. And it's also difficult because there's this gradient of light in the image that's blinding and making it tricky to see. So I'm also trying to fire up a telescope on itelescope.net in New Mexico to get some simultaneous images of it for fun parallax measurements or whatnot, if possible. It's right around here, and boy oh boy, do you really need a powerful telescope to see it. I mean, with the 8-inch, this would not be possible. It wouldn't have even shown up at all, I'm pretty confident, even with long exposures, unless I was doing direct tracking. James Webb is extremely dim now at the L2 point. But it is possible to see it in theory. And it is, like I said, it is, I think, showing up. But the individual frames, you really can't tell. You need to see it in motion to really pick it out. So I will have some processed frames here in a bit. In fact, I might be able to pull up. Yeah, it's on the cloud, so I can pull up the video. It's not going to look like much. It might not even come through on the streaming compression, which is what I'm concerned about. But I will try. Okay, I'm going to try. Okay. It's extremely dim. So if I move this up, where's my text? Where are you, text? Text? Okay, I'm going to just delete and create a new layer. It comes in, okay, so in the live frames it should be somewhere in this area. It comes in and moves over this way in the time lapse. I'm not sure where it's at this point. I'm going to blow the heck out of the time lapse. I'm going to blow it up. Yeah, I can see it. I can see it with my tiny little eye. Oh boy, it's real hard. Real hard to spot. It's there. It's moving from from right to left in the frame. And it's just to the right of the cursor. At the end of the time-lapse loop, it stops right where the cursor is, basically. And I don't know if you can see that. It's extremely grainy, it's extremely faint, it's extremely hard to get it, but it's there. It's there. So I'm going to go check on the telescope in New Mexico. I'm going to go check on that, and then in a bit we will get some calibration frames, and I'll recalibrate, because right now there's this gradient in the time lapse which isn't helping as well. I mean, it'll still be grainy, but if the light level in the image is more even, it's easier to crank the contrast even more and make it stand out. So that's the hope, because at the moment I really am not even confident that you guys are able to see it at all on account of the streaming compression, just on top of the overall difficulty of it. But it is where I expect it to be coordinate-wise, and I'll show you what that looks like here in a second. I did pull the coordinates on it. I did do astrometry, and I did confirm it's right where it should be in the frame, according to SAO image DS9. So I'll pull SAO image up in the background, and I'll show you guys in a second once I've got it on this computer. Yeah, why can't you load that? That should be something you can load. Okay, let's rename the file type. Guess it doesn't like that. Okay, try again. Yeah, okay. And I really have to crank the max out of the contrast, but it is there. Okay, regions. Let's load the regions. 11. And you'll see what I mean when I say it's just barely above the noise floor of the image. Regions. Font, let's make that. No, okay. I had to go and screw that up. Okay, I've got to reload the regions again. Current frame. Okay, there we go. Region, get information, font. Let's blow that up. Width, let's make that thicker. It's not... It's green against black and white. It's not great, but it's just what I got to deal with here on SAO image DS9. Okay, so... we add another window capture here. Yeah, great. So you can see now SAO image view here is inverted. Actually, I should uninvert that compared to the time-lapse view. There we go. Okay, so now it's the same orientation. So you can see that those three stars in that triangle near the arrow on the time-lapse is reflected as well in the single frame in SAO image DS9. And the green circle represents the predicted coordinates of JWST according to JPL. And you can see right in the middle of that is a little dot, very faint, but it's there above the level of the grain and the noise in the image. So that is James Webb, for sure. That's exactly where it should be. And you can see it here in the time-lapse. It's actually moving across the bottom star in that triangle, as it were, those three brighter stars that are in a triangle. It moves from right to left, right over the bottom star in that triangle. And you can see that in the video. Well, I don't know if it's coming through the streaming compression, as I said. I'm hoping it does, but I don't know that it does. I'm going to blow this up one more time, make it even bigger, and really try to bring it out. Okay. Okay, there we go. That's as good as I can get it at the moment. As I said, I'm going to go check on telescope in New Mexico, and then I'm going to come back. We're going to grab some calibration frames, and we're going to try to get this better calibrated to reduce the gradient in the image and crank the contrast even more to make it more apparent in the time-lapse video. Okay? So hang on. Okay, so, yeah, to answer your question, I am using a parent RAN deck. That's apparently the correct answer for the newer Celestrons. Yeah, it's a parent RAN deck, but, I mean, it's extraordinarily dim. I mean, you need a big scope to see this. If I didn't have the 11-inch, I wouldn't be able to detect this at all. And I have to say, I have to thank all of you for having this 11-inch. This was paid for using the super chats and ad money that this channel made tracking James Webb the first couple nights, including the first night after launch. So I guess it's a bit poetic that we're now looking at James Webb with the scope that it paid for, but man, only barely. I did verify the scope in New Mexico is taking images right now. I don't know if it'll be able to detect it. I'm using T5 on the iTelescope network, which is 250mm scope. Pretty comparable in aperture to this scope. So again, it might be marginal with the moonlight and everything. It might be marginal, but they do have pretty dark skies out there in New Mexico, so I'm hoping it's got an edge over my scope in that regard. We'll see. I'm taking quite a few images with that scope. I think I set it up for 20 images? I don't know, something like that. At 3 minutes apiece versus 30 seconds, but the longer exposures, of course, are just going to make it streak more. In terms of taking live images, I'm going to try to continue taking live images for a bit longer. Reason being, I want to see, how much of it I can get going, how far across the field of view I can get it going. I mean, it certainly didn't start off in the middle of the field of view, but there's no sense in repositioning at this point. But yeah, I've got the 2-inch nose piece on the camera, but despite that, we are getting some vignetting, which is, I guess, not to be, or it's not unexpected. Tell you what, in the meantime, I'm going to grab a mount for my cell phone camera and take a long exposure shot of the telescope tracking James Webb. It might be fun. Now, I don't know if it updated on this end. I did save a new video with more images from what I had taken. Doesn't look like it necessarily updated here. I'm going to try to get it to re-add. Okay, I don't know if that did anything. Doesn't look like it really did, but yeah, it is what it is. Really, I'm more interested in updating the time-lapse once we get the better calibration frames in there. I guess thank goodness I had a backup SBIG camera. I don't think I could have done this with a camera on the Fritz. I guess that's the good news. Bad news is I have a camera on the Fritz. So, that's not such happy news, but it did give me quite a few years of good service. The original backplate for that camera was signed by Story Musgrave and Dick Covey. And if it's really dead, then I guess I'll put the original backplate on and put it in my display cabinet. Right now, the original signed backplate is sitting in the closet, and I've got a spare backplate on it without the autograph, so I don't mess those up. Oh, and I guess astrometry.net finally did its job. It finally solved the image that I had already gone and solved on my local machine. So James Webb is in commissioning phase. I wouldn't say it's in operation yet per se, but it is being commissioned. The first star we looked at tonight is actually the star that James Webb is currently pointing at and currently aligning its mirrors with. Okay, so it saved those images in the wrong directory. It did save them, but at least they are there. Let's see. I don't really want to do that, but well, I can pull them in here. So I'm not gonna do anything fancy with it just yet, but I will try to share that image on screen here so you can see that. I'm not gonna do any fancy stacking or anything, but Oh no, didn't mean to make it that small. There we go. So that was from the start of the stream, so you can see that there. So it's kind of cool. We got to see the same star that James Webb itself is currently pointing at, and the James Webb moving through space very faintly. Alright, I'm going to go check on iTelescope one more time, and I'm going to check one more time on where we're at with James Webb making its way through the field of view by stacking these images over on the desktop and taking a look at the time lapse. So I'll be right back. Alright, so the new version of the time-lapse is now color, although it's not reflected yet in the OBS window here, so let me turn that off for a second. And I'm gonna reload the time-lapse. We also have a time-lapse from T5 in New Mexico to look at as well. Okay, why is that not color? Free up space. And re-download it from the cloud. Try that. Maybe. No? No? Okay. Hang on, I'll be right back. I gotta fiddle with something. Try to get the color time-lapse from the desktop. 1 second. Yeah, okay, so I was trying to sync way too many files. I cleared that queue up a bit. Should be available now. Okay, that looks good. Let's get this on the stream. And it's still not the right version. Okay, cool. How is that possible? Alright, in the meantime, I will show the T5 time-lapse. I don't know what's going on there, but, you know, I'll try to get that fixed. Oh, wait. Looks like it was changing. Let's give it one more chance here. Nope, Nope, it did not change. Okay, nothing, nothing about that was different. In the meantime, this is from T5 in New Mexico. If I zoom in on it, it's there, it's moving, it's small, etc., but it is there. Nope, that's the wrong label. Where's my label? There's the label. There's James Webb from New Mexico at the same time. So we're getting images from New Mexico. We'll be able to measure the distance to James Webb directly using parallax. So that's pretty cool. In the meantime, I'm going to try to figure out what's going on here with... There we go. Okay. Now the color time-lapse is actually loading properly, as far as I can tell. There we go. Blow this up. Blow this way up. More. More. Okay. Yeah, it's faint, but it's there. Okay, James Webb is moving this way. It's doing this in the time lapse from the C11. It's very, very faint, but it is indeed there. Now this, I'm going to try to get fancy here and get both of them now. Obviously, the rotation is a bit different here. Okay, so here's T5 in the upper left. So you can see James Webb moving on T5. Alright, so on the right we have the time-lapse from my scope here in Florida, and on the left we have the time-lapse from T5 in New Mexico. And you can see immediately the star pattern around James Webb is totally different in my images and in New Mexico, even though these were taken at basically the same time because of parallax. So with astrometry we'll be able to measure that and actually measure the distance to James Webb by looking at the displacement relative to the background stars. Pretty cool, huh? Yes, I've got two different telescopes in two different places in the country taking pictures of James Webb at the same time. The one in New Mexico is still taking pictures right now, as a matter of fact. It'll probably go for another 30 minutes or so. I may cut off my telescope before that, I don't know. I'm going to be wrapping up here pretty soon, I think. But before I do that, I do want to grab some calibration images and run this time-lapse one more time, run the processing on the images from my scope one more time to be able to crank the contrast more by eliminating the gradient in my images. But yeah, overall I'd say we had some good success tonight, despite many challenges. Interferometry. Well, I would have to combine the data while knowing precisely how far apart they are, precisely the orientation, all that kind of stuff. It's not really feasible. It would be nice, but it's not as simple as that. It's one thing to do it at the radio wavelengths because it's more forgiving and easier to combine because of the longer wavelength. At visible light wavelengths, combining light with interferometry is not a trivial task by any stretch of the imagination. But nevertheless, we can get useful data out of it. We can actually measure the distance to James Webb by looking at the parallax, which is definitely something I'll be doing. And I tell you what, it's thanks to you guys that we're able to do this. Again, it's because of you guys I was able to acquire this 11-inch beast of a telescope, the Celestron 11-inch NexStar GPS, which has just enough aperture to be able to detect James Webb. As a faint moving dot. So it is technically still within grasp of amateur telescopes, but only just barely. I had calculated that when it reached L2, it would have an apparent magnitude as bright as magnitude 15, but that was assuming a couple of things. Most notably, that was assuming that the sun shield was directly face on to Earth. As it rotates around a bit to point at various stars, that assumption may not hold true. And because of the specular nature of its reflectivity, it's very angle dependent. So, as it points slightly away from Earth, it acts like a mirror, and now the sun shining off of it is not reflecting back straight at Earth. So, the apparent magnitude can be much dimmer than magnitude 15. Magnitude 15 is sort of a best case scenario, perhaps. Maybe it gets a little brighter with specular reflections and flares, but in many cases it may be worse than that, which is seemingly the case tonight. I would say this is probably much dimmer than magnitude 15 tonight, and I had seen reports of it being about magnitude 17, and that would be consistent with what we're seeing here. So when you get down to magnitude 17, to pick up a moving object that's magnitude 17, you really do need a big scope if you aren't directly tracking it, because as it's moving through the image, it's depositing its light onto new pixels very quickly. And so if it doesn't rise above the noise level before it's moved onto a new set of pixels, you will not get a detection, no matter how long your exposure is. It will be an invisible streak below the noise level of the image, so you won't even see it. And that's why you got to bring out the big guns, you got to bring out the big aperture to be able to pick up fast-moving, near-Earth objects that are magnitude 17, magnitude 18, those kinds of dim magnitudes. And this is also why humans can't really detect asteroids until they're right on top of their own planet. You know, we can look for asteroids approaching Earth, but we won't see them if they're small until they're right on top of us. They can be magnitude 19, 20, 21, and the largest telescopes in the world for doing asteroid surveys can still only get down to about those magnitudes, down to about magnitude 21 or so, at the earliest possible detection, which requires that small asteroid to be pretty darn close to Earth before it even gets that bright, and that's much dimmer than what we're seeing here. So that's that's a significant challenge. How did I get access to a telescope in New Mexico? So that is through itelescope.net. I'll post the link in the chat here. You can rent time on it. Yeah, you can sign up for an account. You can also get a trial account and test out one of their smaller telescopes. And if you pay for a subscription, you can accrue money in your account to use on various telescopes. It rolls over month to month. I've got a few $100 worth of telescope time banked up there over many months of being a member, and it's really handy to have that. Their largest telescopes can be quite pricey in terms of cost per hour. You could be looking at over $100 per hour on some of their bigger scopes. But when you have a transient event or something that you want to observe, perhaps something like this, where you want to get two telescopes on it simultaneously from two different sides of the country to do parallax observations, something like that, you can do that with iTelescope. So I find it a very handy tool to have in my tool belt. Also helps in cases where it's cloudy and I'm not even able to observe something from Florida, but I'm able to get on it with iTelescope. And that was the case earlier this week with the close approach of the Discover upper stage, the Falcon 9 second stage, which will be hitting the moon next month. So it successfully delivered Discover to L1, a Lagrange point on the opposite side of Earth, between Earth and the Sun, but it was left in a highly elliptical orbit, and that orbit will carry it into an impact with the moon next month. It will hit the far side of the moon. It will not be visible from Earth at impact, but it did make one last close approach to Earth earlier this week, and I would have liked to have observed it, but it was cloudy here in Florida, so I was not able to get on it with one of my own telescopes, but I was able to get on it with the same telescope in New Mexico you're looking at right here, T5. So I was able to get some images of that second stage booster flying by Earth one last time on its way out towards apogee and eventually towards lunar impact. Thanks, Willie. So, yeah, once again, we're going to be wrapping up before too long, but before I do, I'm going to collect some calibration images as best I can, kind of poor man's flat fields, using the concrete of my sidewalk or maybe the side of my house as a semi-flat field to be able to take out some of the vignetting and hopefully calibrate these images a little better to crank up the contrast and bring out JWST a little bit more in this time lapse. from my images that you're seeing on the right there. Right now, these don't have a flat field applied. In fact, I've never taken flats with this telescope and this camera, so that'll be new. Yeah, it is a pretty good. It's a really good business model. And full disclosure, I'm a scientific advisor for them, but I don't get paid for that position. But yeah, no, it's a really nice business, and again, it's a really handy tool to have. Even if you have a telescope, it's handy to have in case there's something like this, transient event with Discover's upper stage that you want to observe, and you want insurance against weather so that you have, multiple bites at the apple. If it's bad weather in your location, maybe it's good weather in New Mexico or California or one of their other observatories. They have observatories all over the world, California, New Mexico, Spain, Australia. So you can also do Southern Hemisphere observing as well. And if you don't have a telescope, here's a way for you to access very powerful telescopes for relatively little money. You don't have to invest, a few $1,000s to get started. You can just sign up for an account, and for $20 a month, you can have access to very powerful hardware and, at least get a few images, a few short images on some of these bigger scopes. Yeah, that's right. So 250 millimeter scope, like I said, aperture-wise, very similar to what we're using here with the 11-inch. Well, what am I saying? No, that's wrong. I'm used to my 200 millimeter. Well, no, it's not terribly wrong, is it? I can't do the conversion in my head. What's wrong with me? What is that in inches? 9.8 inches. Yeah, no, it's similar. It's just a little bit smaller than my scope. So pretty comparable, and they have got a really nice camera on there. And these are 3-minute exposures from New Mexico versus the 30-second exposures I'm doing with my scope. Obviously, my images are unguided, and without AS tracking, that's going to limit me to relatively short exposures. Yeah. So, yeah, it's funny. In the live images from the scope I'm looking at right now, like, I can't see James Webb at all. I can't tell where it is in the frame. It's invisible to my eye. But that's just from seeing a static single image. And looking at the time lapse, you can, of course, see it a lot easier. And even then, faint. But with the helpful motion of it, makes it easier for the human eye to pick up. But yeah, we're going to go ahead, I'm going to go ahead and stop the live imaging from my scope here. And get one more frame, and then I'm going to get some lights on and start collecting flat fields. So give me a few minutes. I'm going to collect some flat fields and then recalibrate these images and crank up the contrast some more to hopefully bring out the James Webb image a little bit more from these frames on my telescope. Alright, I'm finally back, and I have a new version of the time-lapse to share. As soon as it's on the cloud. Yeah, it's, so, to answer the question, Divine Appointment, it is at L2. It's now in its orbit around the L2 point. It doesn't sit stationary, though. It is orbiting around that point. Here comes the new time-lapse downloading onto the laptop, and then I'll share it on the stream. Okay. Okay, so I don't know how well that's coming across here. I'll try to point it out. It's moving from right to left down here. Still pretty faint, but it is there. I really cranked the heck out of the contrast on this time lapse. I'll do a little more tweaking with it later this weekend and see if I can produce a final time lapse to upload to the channel along with the frames from T5. The image shifted quite a bit in T5 in terms of the sort of the gradient or the stray light. I'm not sure if the moon went into a cloud or behind the observatory dome or something for a moment, but like it changed in the last couple frames, which kind of disrupted. Actually, it might have done a mount flip. Probably did a mount flip, and that might have changed the pattern of stray light coming into the telescope from the moon. So I might drop the last couple frames from the T5 time lapse just because it's jarring when the whole image suddenly changes. But yeah, we'll see. But anyway, yeah, now that'll be interesting, and I'll put that together with T5 and show the parallax and actually measure it and see what I come up with for a distance to James Webb Space Telescope. So again, one more time, it's coming from up here. It's moving down this way like that. Hopefully that's coming through well enough on the stream that you can see it. Yeah, you can see it in some frames. And it does appear to vary in brightness, which again is not unexpected given its very shiny specular surface for the sun shield. If it catches the sun just right, it'll flare up in brightness for a brief moment. So not bad with 30-second exposures, I'd say. I mean, that's difficult to do. Get down to probably magnitude 17 in 30 seconds. That's a tall order. But anyway, yeah, that's going to do it for tonight. So I'm warming up the camera now, getting ready for shutdown. So you think you're in the same spot? Yeah, it's so faint now. I hate to say it, but it's going to put it out of reach for most amateurs, including the former version of myself with just an 8-inch telescope. I mean, maybe if I got on it with direct tracking, but it's moving slowly enough that encoder resolution would have been a limiting factor, and it would not have tracked accurately enough, I think, to show up in any kind of useful way, or maybe even at all. I mean, the 11-inch NexStar is struggling to get it. You know, if I could polar align it and run slightly longer exposures, yeah, it might be easier, especially if I bin it 2x. Heck, if I just bin it 2x and cut the resolution in half, it might be easier to see, honestly. If I do it again, that's definitely what I'll do. I'll start binning the pixels and sacrifice resolution for sensitivity. But successful enough tonight to be able to get some frames with it showing up both in my telescope and in T5 to be able to measure the parallax. So we'll see what we come up with for a distance. Stay tuned for that video in the future. I'm going to wrap it up here. But thank you all for coming. Thanks for watching. If you aren't, please subscribe and stay tuned for future videos. I have noticed that the channel analytics indicate that anywhere from 2/3 to 3/4 of the people watching my videos aren't subscribed. So hopefully I've earned your subscription tonight, and if I have, please hit that red subscribe button and give the video a like, if you will. If you liked this content and want to see more. But seriously, I want to thank everyone for watching, because you guys made this possible. Your viewership, your super chats, they bought this telescope. So I'm very glad to be able to use it to provide you guys live views of James Webb. Oh, you're just in time for me to wrap up the show. Well, I'm going to leave it playing for a few minutes here with the music in the background. But yeah, this is it. We struggled to get it, but we finally got it. Alright, until next time, clear skies, folks.